Okay, so how did you get on with this one? How would you do that? So the first one is quite straightforward, right?
Yeah, work out number 2.
49 is equal to 7 times 7.
7 times 7, yeah. So basically, you should be able to get those two quite easily. I keep forgetting that I've got the wee pen there. So 7 times 7, so we've got him as 7.
Plus.
We've got this as 49. The only one missing is this one. So how do we go about this? So I've got here 49, yeah? How do I find these two? I've got something here. What's 9 take away 8?
1.
1. When did we say that when you divide two numbers, they're equal to 1? When both numbers are equal. So the only way you would get a 1 here if this is equal to this. Yeah? Right. So that means you can put here, these two are equal. It's a bit like 2x, because we're looking for x, plus 49 equal 57. So that's how you can write this using algebra. So using our balancing method, we take away 49 on each side. We get 2x equal 8, yeah? And divide by 2 on both sides. That means x equal 4. There you go. So you've got 4 plus 4 plus 49 equal 57. So that's 4. What's 7 plus 49 take away 4?
52.
Yeah, so that's your answer. Okay, so there's a bit of BODMAS, because when you say BODMAS, you do add before subtract anyway. But even if you had minus here before the plus, you would always do it from left to right. Okay, so that was the answer there. Question mark equal 52. So the only difficulty was to notice that when you've got two numbers, you know that when you divide two numbers, the only time that you'll get a 1 if both numbers are equal. And that's why these two are equal. Okay. I take it that was the only difficulty in here, yeah?
Yeah.
Yeah.
Okay, so what are we looking at today? We are looking at angle properties, but before we can look at angle properties, I wanted us to revise quickly on angles, and we're going to review some of the angle properties that we've probably learned, some maybe we forgot or we don't use enough to remember. And we're going to investigate an isosceles triangles when it's built in within a circle. So these are the type of question that comes quite often when you're looking for angles. Okay, so you'll be successful if we can solve problem using angle properties. Okay, so revision first. The first thing first is angles round a point. What do they add up to?
360.
360, yeah. So it's just a circle, right? So if I have 120 here, 95 here, what's left to get to 360? You do 360, take away 120 and 95. So you should be left with 145. Yeah, correct. So that would be 145. So round a point, angles would add up to 360. So that's one thing we need to remember. Second one, I've got a straight line here. If I've got 115 as this angle, what's this angle left here?
85 to 20.
180.
So remember, if a full circle is 360, what would be a straight line?
180.
Yeah, 180. So what's the angle here?
65.
180, take away 15. Yeah, 65. Okay, so a couple of things. Two angles making a straight line would always add to 180. Now, this I usually call it, the X. What kind of angles do we have? So what's the angle here and what's the angle here? Knowing that if you've got 34 here, you have 34 here. So we've got what we call opposite angle. So what do you think this angle would be? If I use two angles making a straight line, you've got a straight line here. What do you think that angle would be?
146.
Yep, 146. And because that angle is 146, the one opposite to it is 146. So opposite angles at a cross are always equal. So if you find one, you can find the other one. So we're just trying to find some properties to help us identify angles when it comes to it. And the last one in this group here, so we've got a triangle. What did we say about triangle? All angles in a triangle add up to? So if you take that wee angle, you add that angle,
180.
180, yeah. So all angle in a triangle add up to 180. And that means if I've got 50 and 40 here, the only way to get 180, if I add them all three, would be to add an extra 90. Okay, so 4 properties that we will use quite often, but it's basic that we need to know, okay? Now we're going to look at angles when it comes to special triangles. So whenever you're going to see these wee bar across lines when you've got a triangle, it just means that this line is equal to that line. Sometimes you see people writing with a wee equal sign on them. And I've got this other triangle where this line is equal to that line, which is equal to that line. So in math, this type of triangle where two lines are equal inside the triangle is called an isosceles triangle. And when that happens, you've got two angles that are equal. So those are the two angles here, this one and this one, because we've got those two lines equal. And now you can see what's going to happen here. Because I've got three lines that are equal, this angle will be equal to this angle, which is going to be equal to this angle. So I've got three angles. And what did we say about triangles? All angles in a triangle add up to
180.
180. So I've got three of them. 3 times what give me 180? So basically, remember, use algebra whenever you've got something like that. 3x equal 180. What is x?
X. 60.
Yeah, 160, yeah. You just divide by 3 both sides, and that's you. X equals 60. Okay. So all angles in an equilateral triangle are 60 degrees. So whenever you're going to see a shape like this, you know that every angles inside there are equal to 60. So here, I can see a couple of letters. So this is an F. I can identify an F, but I can identify a Z as well. Okay, so we will look at two properties when it comes to what we call alternate angle or corresponding angle. Okay, so H is corresponding to D. So if you see, you've got D here and H here. So if you think about this being an F, so whenever you're going to see this shape of an F given to you, the first thing is those two lines for the F needs to be parallel. So those are identified by the arrow here. So that means this angle here is exactly the same as this angle here. Okay. And you've got the same thing on the other side here. You've got F as well. So A and E would be the same. What about B? What did we say here? Can you see another letter? Remember,
150.
can you see an X here?
Yeah.
So that means B should be equal to, is opposite to D, must be 115, yeah? And C, if you've got 115 here, and you've got a straight line here, then C is just 180, take away 115, which is 65. So we've looked at straight line, F shape, X shape, and E is just the alternate to C. So where is that coming from? So if I change the color of my pen, let me put, if I put yellow, you'll see it. So this is a Z shape. So E is alternate to C. So, and E will be 65 as well. So whenever you're going to see that Z shape, again, these two lines, it's got to be parallel line. That angle will be equal to that angle, which is what we've got here. E is the same value as C. So with just one angle defined here, we can find all the other angles. 115, 115, 65, 65, 65, 65, 115, 115. Okay.
Mhm.
So now we talked about isosceles triangles, triangles with two lines that are equal. So when two radii, so radii is the plural for radius, are drawn to the ends of a chord. Okay, so the chord is just a line cutting your circle. So there's your chord AB. So if you join the two radii here, radius AC and radius CB, you are making yourself an isosceles triangle because that distance, that's what the circle is the same as that distance. Okay, and because we've got an isosceles triangle, you'll see them marked like this with those wee little cross on them. And what we said about isosceles triangle is this angle here that we can call CAB is equal to ABC. So that's how you define an angle. An angle, you write it as, so this is how we write an angle. We come and say, we put this sign and we call it ABC, which is equal to CBA. So you put a kind of L there. That's how angles are sometimes defined. And all those two angles are equal to X here. Okay, so that's how we annotate an angle. ABC, CBA, it's the same thing, and it's the same as CAB. So all these are equal to, again, CAB. Or BAC. So the angle basically is the letter. The angle is defined by where the letter is. Okay. So let's see what we can do. Special properties of isosceles. It's got an isosceles triangle's got two equal lengths. We just mentioned that, and two equal angles. The two angles X and X. And we mentioned that angles in any triangle add up to 180. So now, if I give you an example like this, I'm telling you I've got an isosceles triangle here because you can see that you've got a radius here and a radius there. And if they tell you that you've got this reflex angle of 280, what is the value of x? How would you go about finding x in this case?
Can you go back a slide, please?
Yeah.
See how you were saying there to get two equal lengths and two equal angles. So
Yeah.
if you go back to the previous slide, how would you know when it's just x
So
that they are both the same
so
angles and length?
so basically, if you're given something like this, you'll be shown that that triangle has got
Mhm.
the
Because
two
it's got them in it.
branches. Yeah, the two branches are the same. So basically, it's
Right,
the
okay.
end of the branch where the angle is. It's the same as that angle there. So this angle will depend on once you find these two angles, you'll be able to find that one, because you know
Right,
that
okay.
if you add those two plus that one, yeah, there's
It's
3.
180.
So
Okay.
basically, it's the angles that are tied into the chords opposite the
Okay.
center.
Okay, thank you.
Okay. So that's how, now that I've got 280 here, if I can find this angle here,
80.
so yeah, 360 minus 280 will be 80. Now that I know I've got 80, and we said that all angle and a triangle add up to 180. If I've got 80, I'm left with 100 to share between those two. Remember
50.
this, 50 each, yeah. So that's how you would just say 2x equal 180 minus 80, 2x plus 80 equal 180. So you take away 80 on each side, 2x equal 100, or x equal 50. Okay. So that was an example where we've used the property of an isosceles triangle. And as you can see, it's built inside a circle. Very common in Nat5 type questions when you get angles. So that was the first pair of lessons to show you angles in a circle. So now we're going to use angles in a semicircle. Okay, so we're going to look at angles in a semicircle. We're going to investigate. It's a special angle, and we're going to solve problem using the special property associated with an angle in a semicircle. Okay, so as you can see, I've got a semicircle here, half a circle, and I've managed to build a triangle inside that semicircle. So the key points is that that triangle here, APB, the longest side is a diameter because you've got a radius plus a radius. But opposite that longest side, remember what we used to call the hypotenuse when we were doing Pythagoras? You
Yeah.
have the two shorter sides. And in order to use Pythagoras, we needed to have a right angle triangle. So guess what? Wherever we move that point P, it's always going to give us a right angle triangle. So now what we can say is a triangle within a semicircle always has a right angle triangle. Then that means we could use Pythagoras. Okay. If it's built like this, obviously with the hypotenuse being your diameter. So now that we know that angles in any triangle sums to 180, you've got to sketch a couple of diagrams, and what we've been asked is to find all missing angles inside those triangles. So you've been asked to find that angle, this angle, and this angle. And that's what we've been given. So how would you go about this? And I'll give you a couple of minutes. Okay, so hence, how can we find right angles here? By looking at it, we can see that we've got those two triangles with the hypotenuse being the diameter, or two semicircles. And then we did say that all angles in any triangles add up to 180. Now that we know that these are 90, 90, so 90 plus 43, take away 180 from that, you get 47. 70, so 180 take away 70.
110. It's not 97.
Then you take away 90 to your 110. So 180 take away 70 plus 90, it's 20. Yeah. And it does look like a small angle, because if this is 70, this is tiny, yeah. Does make sense. Okay, so that's how you would find these. So if you wanted to, you could have just sketched them like I just said separately, and you would get the same answer. So now a second example, sketch this diagram, write down two right angles and calculate all missing angles. So again, this is a typical type of Nat5 question I've seen before, where we're asked to find the other angles. So again, I'll give you a couple of minutes. Okay, so again, you can clearly see that you've got a couple of triangles, right angle triangles. So how would you do this? You would look into it and go, I've got this right angle triangle. That means this angle here would be 180. Hold on. Yeah. So I've got 60 and 90. So this angle here inside would be 180, take away 90 and 60. That would be 30 degree here.
Yep.
Probably gonna have to change that color. So now I've got 30 plus 25. That's 55. And I've got 90. So 180 minus 55 minus 90. That tells me this is 35.
Yep.
So if I want to find E, I've got 25, 35. We said that all angle in a triangle add up to 180.
120.
So that's
So I've got 120.
120 for this one, yeah. Now I need to find that angle. You've got an X shape here. It's the one that might not be that straightforward to find, but that's 60. So I've got 60, 90. And that means here
30.
I've got my 30 as well, yeah. And I've done all the angles, 30, 35, 30, 25, 60, 60, 120. If you want to be pedantic, you can say that that's 120 as well. Okay.
Yep.
So that's how you would solve that, by just using some of the techniques. So as a plenary, I just put here things to remember. This is in your book, the Lecky Lecky. So alternate angles, you've got the Z shape, and they point to you by showing you that those two lines are parallel lines. So you've got that angle is equal to that angle. When it comes to corresponding angles, you've got this here, the F shape, I call it. So you've got that angle equal to that angle. And when it comes to vertically opposite angles, so you've got this angle equal to that angle, but you could have add as well that this angle here is the same as this angle. Okay. Angles in a triangle, we said they add up to 180. So any triangles, when you add them up, all angles add up to 180. The one that is often missed because it's something that was probably done in primary school and forgotten about is in any quadrilateral, like any shape with 4 sides, quad just means four sides, all angles add up to 360. So this is another a property that is missed quite often. If you want to convince yourself, just draw yourself a rectangle, and you'll find out a rectangle has got 4 right angles. 4 times 9 is 360. So you can quickly double check that for you by just drawing a rectangle. Okay. So 5 things, line properties and shape properties, quite good to remember when you're going to be solving problems involving missing angles. So I've got some example here. I've been given triangle ABC, so A, B, and C, so that's a triangle. Been told that it's an isosceles triangle, so you can see why it's isosceles. Quite straightforward, because I've got this here equal to this line. So I know that these two are equal. Calculate the size of angle ACD. So I've been asked to find this angle. How do we do that? The first thing we do is, because we've got an isosceles triangle, I know that when I've got an isosceles triangle, this is 28. All angles in a triangle add up to 180. So 180 minus 28 twice is 124. So I've got my angle here, 124. And because this is 124, I've got a straight line, 180 minus 124, and that is 56. So that was what they asked us to find, that angle. And during an exam, you can just write them like that. You don't have to show all your working. If you wanted to show your working, you can just say that here you've got 180 minus 28 plus 28 if you wanted to. And that's 124. And then 180 take away 124 equal 56. But again, you don't have to. Okay. Using properties we've just looked at a minute ago. In B, we've told that we've got a quadrilateral here. We've been given some other angles. Now calculate BEF. So I'm going to find out where BEF is. So this is F. So BEF is this angle. How can I find this angle? I'm going to use the quadrilateral property. So if I've got 103 here, I've got a straight line here down. So what's the value of this angle?
73.
So
77.
77, yeah. So this is 77. So now that I've got this angle, I can do the exact same here. 180 take away 118, and that'd be 62.
Yep.
So I've got X here, shape. That angle
that 95.
Opposite to it is 95. There you go. So I've got now 3 angles inside this equilateral, and I know that all angles here add up to 360. So I'm just going to take away 360, 95 plus 77 plus 62, and you got 126.
Yeah.
Yeah. So you see, when I get 126, I can see straight away this is bigger than the right angle. So it makes sense, and it's less than 180. So that's how you would find B. For C, very similar again. What I've got here is a Z shape there. Can you see that they've even told me that? So I know that this is 43 alternate angles. If this is 43 and this is 85, angles in a triangle add up to 180. So you do 180, take away 85 plus 43, which is 52. So straight away I've got 52 here. So I've got again another Z shape here given to me by these two. So this is 85, corresponding angle. So you could figure out what this is if you just say same thing, 85, 43, it's got to be 52 because 180. And you can double check that 85 plus 43 times 2, 256 minus 360 is 104, which is double these two. Okay. So let's have a look at this example here. BC is parallel to AD and triangle ACD is isosceles. Calculate ACD. So I've been asked to find ACD, this angle there. So how am I going to do this? I'm looking at this and thinking, okay, I've got a right angle triangle. I've got a triangle here. So if I've got a triangle, all angles within that triangle add up to 180. That means this is 52. Yeah. So now I've got this Z shape again. It's not straightforward to see, but what is pointing me towards that shape is those arrows, alternate angles. So this is got to be 52.
52 as well.
And 52 across because it's an isosceles. So 180 minus 104 is the angle that I'm looking for.
76.
76. So just step by step, we use the properties that we've been looking at, and you can see you'll get through. So the difficulty, I would say, in this example was to spot that you had a Z shape there. But again, look for those arrows. They're pointing you towards what you should be looking for.
Yep.
Okay, so the next 2 slides is just giving you step by step the working that we went through. Okay, so this is the working basically, if you want to find out how we managed to get all our answers.
Do you need to show, you don't need to show that working? No, you said it.
You don't need to, you can just do it the same way we've done it here. Oops, the same way we've done it here. You'll get the same mark for whoever's going to do all the working, as long as you can see, yeah, it shows step by step. Okay. Oops. Yeah, so this one, I didn't give you the working, but we went through it. So the first homework on angles is going to be chapter 21, page 220, exercise 21A, and it's question 1. So it's very similar to what we've been doing on most of those examples. So there's few techniques, I would say, those properties. And unfortunately, I see a lot of students skipping those questions because they just say, oh, I can't see exactly what they're telling me. But if you can extract the 5 properties that we looked at, then with a bit of practice, I think you should be able to get those marks quite easily. So let's have a look. So basically, you've got
a question like this. How much would that kind of question be in an exam?
So in this one, for example, find the size, because I've got to find one. So this would be for a simple like that, it'd be 2 marks, right? Because you've got to find that angle, and then once you find that angle, you find that second angle. So that would be 2 marks. But what you'll find is these wee questions are buried into another question, so they'll probably put a circle around it, for example, and that might be a chord, and then you've got to find the length between that and that using Pythagoras, for example. So that could be another 2 marks added onto it. Okay. So what we could quickly have a look. So you've got 6 of them. 1, 2, 3, 4, 5, 6. I'm going to do one with you so that you can see the step by step how I'm going to pick the one in the middle. So A, B, C, D. Yeah, let's try D. Okay. And I'm going to show you how I'll go about D. So D, I've been asked to find that angle. First thing first, I'm looking at the wee hints I've been given. So the first thing is, okay, they've not told me anything, but they've put a wee line here and a wee line here. They're telling me this is isosceles triangle. Straight away, because it's isosceles, I know that this angle is 81. I'm just using what they've given me. Because if this is 81, this got to be 81 because those 2 lines are the same. And I know that adding all the angles in a triangle give me 180. So my angle here has got to be 180 minus 81 plus 81. And that's 18. So I've got here 18. I've got 81. I've got 43. And I'm missing D. So this is the bit where you're going to look outside the box and say, oh, I can see another triangle there. So with an angle of 43, an angle of 81, the missing angle is this big angle here. So 180 take away 43 plus 81. So that big angle there is 56.
I think we've already got 18 degrees of that.
And then to find D, you just say that D is 56 minus 18, and that's you've got your answer.
38.
Yeah. And that's how you would get an easy, that would be 1, 2, 3. That could be even 4 marks. That could be 4 marks. 3 as a minimum, but you can see how they can give 4 marks. 1 for this one, 1 for this one, 1 to find the 56, and then to do the last operation.
I'd happily take that as a 4 marker.
So they're not difficult marks, but I guarantee you a lot of students, when they see this, they go, oh, I can't be bothered going through this. It's just breaking it down and trying to see. Okay. So X shape, Z shape, F shape, that's usually what I tell my student. A triangle, is it isosceles, is it equilateral? Have I got a quadrilateral? Okay, so now we're going to build, now that we've got these were revision, by the way, those are not 4 type revision. So you need to bring all that into now the NAT 5 because they're going to use now Pythagoras associated with those triangles. Okay, so let's see how we can do it. But if you don't have those bases, it's hard to get, you know, the 5th and 6th marks associated with what we're going to look at. Okay. So how we can use Pythagoras to calculate length when you've got triangles embedded into circles. So that's what we're going to be looking at just now, okay? We're going to solve problems using Pythagoras theorem. Okay? So we've been interested in right angled triangles within a semicircle. And since they are right angled, like I said, we can use Pythagoras to calculate missing length. Oops, can you still see my screen?
No, I can only see like the white. Yeah, that's it now.
Yeah, for some reason, when I pass by, I need to be careful. So I need to remove this line here. So let me, yeah, raise pen. So calculate the value of D. So we're going to use Pythagoras. We've been asked to calculate the value of D. So here there's no angles involved into this because I'm asked to calculate a length. Remember Pythagoras, we said the long side square is the sum of each of the shorter side square. And once you've got those two short sides squared, you just took the square root of that to get D. So that's how you use Pythagoras. Basically, D square is AP square plus BP square, 4 square plus 3 square, which give us 25. Now we're looking for D. The opposite of squaring is taking the square root. So we need to square root both sides. That means D is square root of 25, which is 5 centimeter. Okay, so this is what we call the perfect right angle because you can see there's no decimal to a 3, a 4, and a 5. Okay, so calculate the length of xy. Xy is a short side, so this time instead of going for adding, we're going to take away 10 square minus 8 square. Then that means xy is square root of 100 minus 64, which is 6. So these are revisions of Pythagoras. Okay, so 6, 8, 10 is another perfect Pythagoras triangle. So we've looked at Pythagoras. Now again, let's look at SOHCAHTOA. Some of you might remember, some might not. But SOHCAHTOA is just looking at using right angled triangles again by saying that if you've got an opposite side and a hypotenuse, you can find the angle associated with those two sides. So let's have a look. So SOHCAHTOA is what you need to remember, and then we're going to try and solve. So let's say we've got this again, a right angled triangle within a semicircle, and we've been asked to calculate the value of x. So you just write what you have. So at the moment, I've got an opposite side of my angle, and I've got an adjacent side as well. So opposite is 3, and adjacent is 4. So if you take the opposite and the adjacent, that means you can use tan. Tan of x is just opposite divided by adjacent, which is 3/4. Then you would get your calculator and use shift tan on your calculator. And that should give you the answer, x equals 36.9. And you're allowed to just put 1 decimal place if they've not told us. So you can get away with that. Okay, to 1 decimal place, we found the value of x.
Okay.
Again, those are revisions from Nat 4, but they've embedded the triangle. So in Nat 5, they can just put the triangle without telling you that this is a right angle, but you should know that this is a right angle. And that's why you can use SOHCAHTOA. So now if we're asked to calculate a length when we know the angle, again, we've got a length which is adjacent length. And we know the hypotenuse, so we know A and H. So you just tick the two that you know. So that means cos of 67.4 is AB divided by hypotenuse. Okay, so this is how you write it. You just say cos is adjacent divided by hypotenuse, which is your longest side. And you know that your longest side is the side opposite to the right angle, which is 13 here. So once you write that, AB divided by 13, you use your calculator, make sure it's in degrees for your setup, and then AB is just, then you time by 13 both sides using your balancing method. You just type 13 cos 67.4, and that should give you the answer. Oh, I've got them set up.
I got 4.99.
Yes, 4.99, or you can just say 5.0 if you just want to do 2 decimal place or something, or 1 decimal place. Yeah.
It's just I do remember this briefly, Adrian, but it's just always remembering what to apply, if that makes sense. Just,
Yeah.
you know, when it comes to talking to words, just trying to remember.
Yeah. To not leave yourself open, I would just say 5.0, and I've rounded it to 1 decimal place because you've used your calculator. And that's because you saw 4.99, you've decided to put 5. Make sure you put 5.0 and state what you've done. Okay. So 5 centimeter, 13 centimeter if you got 67.4. So the last thing we're going to look into when we come to having in a circle is what we call a tangent line, okay, to the circle. And I think have we done kite before? No, not yet. So a tangent line is a line that touches a circle at only one point. Okay, so if I give you that as the definition, how many tangent line can you see here?
2.
Yeah,
Yeah.
the yellow one.
Yellow and the pink.
The other one's to the
And yeah,
pink.
basically you can see 2 of them because they only touch at one point. Okay, so now the radius of the circle that touches the tangent line is called the point of contact radius. So if I was to go from the center to the point where I've got my tangent making a contact with the circle, we call it the point of contact radius. And this has got a property. When you put a point of contact, so here we can put 2 points of contact. This point of contact is always perpendicular. That means it cuts that line in a right angle. So you see here, from here to here, or from there to there, it cuts it at a right angle. Same for this. Here you've got a right angle, and here you've got a right angle. Okay, that's the property basically. The point of contact radius is always perpendicular to the tangent line. Okay, so let's say we've been asked to, so this is proper Nat 5 type question now. Find the length of the tangent line between A and B. So we've been asked to find the length of AB. I've been given here a radius, but I've been given that length. So how can I go about this? If I know that this is right angle. So you can use the property of your right angle. So right angle triangle property is what we call Pythagoras. That tells us 10 square is 8 square plus AB square, or AB square is 10 square minus 8 square, or AB's square root of 10 square minus 8 square, which is square root of 36, and that is 6 unit. They've not told me if it's 6 meter or 6 centimeter, just leave it as 6. Okay, so you would just write here 6 once you're done, or AB equals 6. You can just write that there, AB equals 6, or you can put it onto the okay. So in summary, this is what we've looked at, which is the Nat 5 part of putting triangle within a circle. So the thing that you need to ask yourself is, whenever you're going to see a triangle within a circle, so is there an angle in a semicircle? So that'd be the first question you could ask yourself. If you see it, you know that this angle is right angle. Is there an angle between a tangent and a radius? So that would be your second question. If you see that angle, you can tell straight away this is right angle. Or is there an isosceles triangle, meaning that the triangle formed by a chord here and 2 radii? And you know that this angle is exactly the same as this angle. And if you're given this angle, you know that 3 angles in a triangle add up to 180. You can just find these 2 and it's half them to get the value. Okay, so let's have a look at the Nat 5 type question that we could get. We've been asked in this question here, O is the center, PQ is a diameter, so we can see it there. Calculate SQR. So we've been asked to find this angle here. So question we need to ask ourselves, do we have a right angle triangle? Because we can see that, yeah, you've got a semicircle here. Once you can see that you've got your semicircle, you can tell that this is 90 and this is 90 as well. We've got 2 of them. If this is 90, this is 47, then we know how to find that angle there. So 180 take away 47 plus 90 is 43. So we can tell that this big angle here is 43. Now we've got 43, and what we need to find, you take away 20 from it. So 43 minus 20 is what we've been looking for,
23.
and which is 23. And I think I know why a lot of students would just not bother going through that kind of question, because they usually say, oh, this is only 3 marks. There's too many things that I can't remember. And they don't have like the basic wee properties that they need, you know, embedded in their head to say, oh, I need to pick that, or I need to pick that. And there's not that many, but because they don't have that, they just go, I'm not going to be bothered about 3 marks. Okay. Which is not difficult mark to get. So this is what we just did. We've got angle in semicircle, angle between, no, so we didn't get an angle between tangent. So basically these are the 3 questions you ask yourself, and then you go through the checklist, identify 43. And once you've got your 43, you can get your 23. That's what we've just done, okay? Now, for this one, I don't have angle in a semicircle, but I've got a tangent there. Yeah?
Yeah.
So that means this is 90. But this is 90 as well. Right up to the tangent line. We've been asked to find a DCB, so D, C, and B, which is this angle there, where C is. Remember the nomenclature? You look for the angle with the letter in the middle. So if I'm asked to find DCB, and I know that this is 90, the other thing that I can notice is, they've not told me, but these two are equal. So if this is 20, and this is a right angle,
70.
that's got to be 70, yeah. And
I
if
mean,
this is 70, because I've got an isosceles triangle, that is 70 as well.
and then BOD would be
And because
40.
I've got a triangle, 2 times 70 is 140, that's got to be 40. And I've got 40, 90, and I can find my wee angle there. Because it's 180 take away 70 plus 40. So let's have a look how they've done it. So draw the diagram. Oops. Yeah. So we found out those two. This is 20. Identify. So where were we? So 70. So I said 70. So I've got 90 here.
Yep.
40. So 130. 180 take away 130.
It would be C.
So that would be 50 here.
BCO would be 50.
Yeah, so you can get 50 here, but even if you didn't get it that way, you could have said that, you see here I've got a straight line, 70, so that would have been 110. And because I've got 20 here, that wee line is telling me this is 20. 110 plus 20, that's 130, and that would be 50. So you've got a couple of ways to get this one. Okay, so you can see it's a bit tricky because it's embedded where you've got a circle portion, a triangle, and another triangle. So when you see 3 lines, it could lead into, yeah. So I wouldn't have drawn it that way if I was giving it during an exam. But yeah, you see that 20 to me, it's not clear.
Yeah.
It's probably better to say this and remove that wee line there and just say that is 20 and put it in red or something. And I can see why some of these questions would put off someone, because it's already quite confusing because you've got a wee semicircle there. Okay, but it's never going to be between, you know, a bowed line and a straight line. An angle is always between two straight lines. Okay, so that's why 20's got to be between those two. Okay, so sketch shapes again. So 21B. So this time you've got question 1, 3, and 7. We'll have a look at an example and then we'll take a break, because we've done quite a lot of angles in circles. So page 225. Okay, so let's have a look. So I said question 1, 3, and 7. So 1, 3, and 7. So you've got 3 questions.
Must admit, I hate sketch. I really didn't like it, especially in school. Sketching shapes was just.
Is that quite? Yeah, so let's have a look. We're going to try this one, right? So I've got O is the center. So KLM, which is that long line here, tangent, calculate the size of angle Q. So I've been asked to calculate Q and P. Okay, so it's this angle here that I've been asked to find. Okay, so how do we find this angle? I'm just going to look what I've got here. So
yeah,
if
straight away.
Yeah, so
That's a right angle.
Q and P. So we need to be careful, because I've got 52 here and I've got a tangent here. So I know this is 38, right?
Yeah.
So that would be the first angle that I would put 38 there. So what else have I got? I've got 48 here. Then I know what that is.
That'd be 42 on the inside.
Yeah, 42. So the other thing is,
You've got a right angle.
because I've got,
angle.
yeah, because I've got a half semicircle, this is 90.
Yeah, and NP.
So that's 90 degree. And I've got the same here. This is 90. That means I've got an angle, something to find. Same on that side, an angle, something to find. And if I add them up,
You need to make 180.
yeah. Or 3, so you would say 180 minus 90 plus 38 is going to give me 52.
The larger side of the
And the same on that side,
48.
48. And then you add them up, your Q and P, angle Q and P here. Equal 100 degree.
100.
Okay.
Yep. Cool.
So we could have said as well that instead of using triangles, you can see that you've got a quadrilateral here. because I've got 90 and 90, and I've got 42, 38, then that would as well would be, so you've got 80. In order to get 180, you would need to add 100. So you could have gone with the quadrilateral, but even without knowing the quadrilateral, if you know the property for the triangle, that should be enough to get you out of jail here. Okay. So you've got two ways to get it. But I like triangles because they're usually quite often you see them into Nat 5 type exams embedded into circles. So if you work with your angles, then you should be okay. Here you'll notice you've got a radius and another radius, so that'd be isosceles again. So you've got other things to help you. The first one is probably, again, right angle there. And 21C and 21D. Couple of questions. So question 2 and question 2 and 3. And I think these are probably more into context because these are the type that you would see during an exam. Some of them are called like, so 2, 3, 2. Let me bring my book. Sometimes people call them like tank type question because you always ask to find a water tank or a bridge, tank or bridge or water within a pipe type questions. Very, very common. So this should give you, yeah, so you can see here a gate. So we'll take a 10 minutes break because it's coming to 7:30, and then I'll go through a couple of these questions with you guys.
Okay.
Okay. Just to show you how you would step by step going through this. Okay, so see you in 10 minutes.
Oh, somebody's asked a question, Adrian. What question was that there?
Hold on.
Was asking.
Do I need to share again? Hold on. Share my screen. So I'm going to share my screen quickly. Is that okay there? Can you see my screen? Hello?